Okay, I'm going to model how we can create lines of insulation for our insulation performance assessment. I have here just a blank sheet of paper, and I'm just going to model creating a ground line and a normal line first. So for our ground line, we're going to just arbitrarily choose a place of the paper to create a flat line. We can label that, that's ground. And then we always refer to our angle of insulation against a normal, and so what I'm going to do is I'm going to make a mark right here below that center icon there, the point of intersection, and I'm going to make a line at 90. I'll turn my protractor and I'll connect those 2 points. This will be my normal line, so I'll call that normal. I'm going to show 3 locations to show their line of insulation or their angle of insulation. The first one I'm going to do is at the poles, so 90 degrees. And we'll just say, let's call this the North Pole. I don't know why I just wrote an N. North Pole. Wow. Strange handwriting day. That's okay. North Pole. At the North Pole, on vernal equinox or fall equinox, the light is coming in at 90 degrees to the normal line. It's coming in like this. And so what I'm going to do is I'm going to hold my protractor here. I'm going to make a point that's going to represent 90 degrees to that, so I'll make a point at 0. And then I will connect, oops, what I didn't do there was show where it needs to connect to. There we go. I'm going to mark right here on that point there, and then connecting this dot to that dot, and draw an arrow, and I'll say angle of insulation. So we would say on equinox, 90 degrees north receives a 90 degree angle of insulation. It's 90 degrees to our angle that we call the normal line. Let's do another one. Here we're going to go to the equator. And this is 0 degrees. At the equator, on equinox, the light comes in at 0 degrees to the normal line. And so here, I'm going to choose to draw it parallel. So I'll draw a mark here. Oops, sorry. I'll draw a mark right here. And I'll draw a mark at 90. And we'll draw it parallel to my normal line. And that's because I wouldn't be able to show the difference between normal and angle of insulation there. Angle of insulation. That's for the equator. Now let's do someplace interesting. Let's do a place between the equator and the poles. Let's do Granby. Filming. Okay, at Granby, Connecticut, we're at about 42 degrees north. At 42 degrees north on our vernal equinox day, we're going to receive an angle of insulation that's at 42 degrees. This is 40, this is 50, this is 45, this is 42 right here. I'm going to connect that to my angle of insulation, so I'll do that right now. And I will label that angle of insulation. We'll draw a nice arrow there. Okay. That is part of your diagram that you're going to have for part 2. The other thing that you'll need to add here is a solar panel, and I'm going to let you figure out the angle that that solar panel should be placed at. Should it come against the angle of insulation line like this or like this? You'll need to use your protractor to determine its appropriate placement. Okay. I hope that's helpful. You're going to have to take over from there.